Hello, are you confused about mole conversions using the factor label method? Or perhaps in multi-step problems you're not sure when to multiply or divide or when to use Avogadro's number or molecular weight? Well, hopefully this map will help clear up all that confusion. In the past, you've learned to calculate moles to grams, moles to gas volume at standard temperature and pressure, and moles to molecules or atoms, or really anything. This map will show you how to put all those concepts together so you can clearly see when and where you need to use each of these calculations. Right now, I'd really like for you to pause this video and copy down this map. Together, we're going to fill it in with the information you already know. Okay, let's start filling in this map. There will be problems where they give you the number of moles and they will ask you how many grams that will be. So we'll take our number of moles and we will multiply by molecular weight. And the molecular weight we can find on the periodic table. So I'll just write that in here so we don't forget it. And for use with our factor label method, the label on molecular weight will be grams per mole. If we're given the number of grams and we want to find out how many moles that is, we are going to take the number of grams and we are going to divide by the molecular weight. So our conversion factor when we convert moles to grams or grams to moles is molecular weight. Another type of conversion is converting moles to things, and in chemistry we're usually talking about molecules or atoms. It could be electrons. So if we're given the number of moles and we want to convert it to things, we are going to multiply by, you got it, Avogadro's number, which is 6.02 times 10 to the 23rd. And for our factor label method, that will be things, which could be molecules or atoms, whatever we're converting it to, things per mole. And if we want to go from the number of molecules or atoms and find out how many moles it is, we are going to divide by Avogadro's number. And you can see here there's a pattern forming. If we want to go from moles and convert it to something else, we're multiplying. If we want to take things or grams and go back to mole island, we're going to be dividing. The last thing we have on our map is converting moles to gas volume at standard temperature and pressure. And to go from moles to one of the other islands, we are going to multiply. And in this case, our conversion factor will be 22.4 liters per mole would be our label. And if we want to convert the gas volume back to moles, just like the other islands, we will divide. And here our conversion factor is 22.4 liters per mole. Okay, so this is how we're going to use this map. Every time we go from one island to another, we're going to run everything through mole island. So for instance, if they give us grams and we want to find out how many molecules or atoms there are in that amount of grams, we are going to simply follow the map. So we're going to use this arrow, which means we divide by the molecular weight to get to moles, and now we're at moles. And then we are going to go, let's say, from moles to number of atoms. We are going to multiply by Avogadro's number. It's that easy. So you may be asking yourself, why do we have to run everything through mole island? Why can't we go from grams directly to gas volume? Well, you can't do that because the sharks will eat you. Also, we don't have the correct conversion factor to go from grams to gas volume. We have to run everything through mole island. Okay, they gave us 25 grams, so I'm just going to put 25 grams right there, and we are trying to find out how many molecules or atoms. So our path is going to be from grams over to things. Okay, let's try this problem. How many molecules are in 25 grams of H2O, also known as water? So in this problem, we're given 25 grams, and we are looking for number of molecules. So let's go back to our map and see what our path will be. The first thing you can see we're going to do is we're going to divide by the molecular weight. So let's go do that now. Okay, we need to divide by the molecular weight of water. and so we need to calculate that, and we can get that straight off the periodic table. So water, H2O. Hydrogen is 1 atomic mass unit, but we have 2 of them, plus oxygen, which is 16, and so that will equal 18, and our molecular weight label is grams per mole. So we're going to take our 25 grams and we are going to divide by 18 grams per mole. But to simplify this, when we divide by 18 grams per mole, it's also the same as multiplying by its reciprocal. So we have 25 grams and we're going to multiply it by its reciprocal, which is 18 grams per mole. And you see this makes our factor label method much easier. So grams will cancel out and we are left with moles, which is exactly what we want, and that will be, to keep it in significant figures, 1.4 moles of water. Okay, now let's go back to our map. We have 1.4 moles, and we are now going to multiply that by Avogadro's number, 6.02 times 10 to the 23rd, to get to things. 1.4 moles times 6.02 times 10 to the 23rd molecules per mole. And using our factor label method, our moles cancel out and we're left with molecules, which is exactly what we want, which is 8.4 times 10 to the 23rd molecules of H2O. And that's our answer. Okay, so to review, using this map, when we want to go from moles to something else, we are going to multiply. When we want to go from grams, gas volume, or things back to moles, we're going to divide. We always have to go through mole island. We can never go from an exterior island to another one. Everything goes through mole island. So I hope this cleared up some factor label confusion for you and showed you a really clear path of how to use mole conversions. See you next time.